Hey guys, today I'm going to be showing you guys how to create a rainbow orbiting holo trail, or an orbiting rainbow holo trail. Because it was requested by a few people, so why not? Alright, and also I'm going to be using OBS Studio, which is a new type of thing I'm not used to, so just try to get this. Let's zoom in, there we go. Alright, so for this code, we won't be needing any type of value, no triggers, no nothing, just persist. And I just wrote a little note here to remind us of the types of colors we're going to be using. So let's get our first block, our runOnTick, because that's always important. We need the code to run, and we will be creating our holograms. A little shortcut here. You can hold Control and press D, and it will duplicate the line under it. So just duplicate this so we have 6 holos being created. Oops. We'll do 1, 2, 3, 4, 5. Alright. And also, we want to do holoAlpha, which is a function that will allow you to set the alpha of a hologram, because we don't want to be able to see the actual hologram itself. So we're going to make them all invisible. That's what, so like the first one, we're selecting the ID of the hologram. And then the second parameter is we're changing the alpha value to 0, which is invisible. Next thing we want to do is set the actual trail color. So we have to get the entity of the hologram, and we will set trails, which is a function to give an entity a trail. This is quite a bit of parameters. So the first parameter is the start size of the trail. We'll set to 5. Next parameter is the end size of the trail, which we'll set to 0. The next parameter is the length of the trail, which we're going to set to 3, which isn't too quick to dissolve and isn't too slow. So it's kind of just right. The next parameter is the actual trail itself, so it's in the trails file. You could use smoke. You could use laser. Laser. You could use fizz beam or love, which is like a whole bunch of hearts. But we're just going to use smoke. The next one is the actual color. 25500 is red, because that's the first one that we want. And then the last parameter is the actual alpha of the trail itself, and we want that to be opaque. So just perfect. Like if you want it to be transparent, you could set it to 125. That'd be like 50% transparent. Or you could do it less. It's all up to you. I'm going to leave it at 255 just for the sake of the tutorial. And we're going to Control D that down till we have 6. And put in the IDs. And we're going to have to change some colors here. So this one will be orange. This one will be yellow. This one will be green. This one will be blue. I'm doing a light blue for this because I just think light blue is a better color. It contrasts better against the darker purple that I'm using. But it's all up to you. You can completely adjust all these color values. It's red, green, blue, so mix and match, it's all up to you. Then let's get our variables started. So up in the persist, we'll put O, and we'll assign that as an entity. Then we'll make another column of values X, Y, M, and D, which we will make numbers. So first let's start off with our O. We'll assign that as an owner, which is us, because we need to be able to have our position. The next number we'll do X, which is just the X, which is just the X coordinate. Y is just the Y coordinate. Which we don't actually have to use, as I've thought about. I mean, I'll leave it there just for the sake of math, because some people like to think in X and Y planes, so I'll leave it there just for that. But you can just use one variable, because we're not going to be changing them for different values. Anyways, it doesn't matter. And for M, this will be, you can think of M as the multiplier or the speed at which the rainbow will orbit you. we want it to orbit us at a speed of 3, which, like I said before, is not too slow, but not too fast. It's perfect. And then a distance will be set to 50. We will be timesing this number against the cosine and sine value that we get from our function that we're about to make, which will basically give us the distance between the trail or the holograms and your player model, or your player center, basically. So down here, outside of the first block, we have to make the actual positions. So the position of the first one, which is the red one, we have to get the owner's position, which is us, plus our own vector, which we have to make up, which will be, if you know any pre-calc or any type of math like that, dealing with angles, you'll know that cosine is dealing with x and sine is dealing with y. So if we want to deal with x first, it would be the cosine. And we put x in there, times it by our multiplier, by our distance. And then the next value, which will be our y value, will be dealing with sine, which is y, times that by the distance. And then we will just assign it a height, which, because red is going to be on the top of the rainbow, we want it to be around 60. Yeah, I'll put it at 60. And then Control D, duplicate this down until you have 6. Assign your hologram IDs. And these numbers won't change except the height, because we want them to actually not, be all bunched up. And now for the last little bit, we need to actually change the variables. So x plus equals m, which will be the speed, and y plus equals m. Like I said at the beginning, we could just use x as both of these values here and here, because we're doing the exact same calculation. But to make it a little bit easier to understand, we'll use x and y. And by the way, for those of you that don't understand the shorthand, what I wrote is basically equivalent to this. You're taking x, plussing it by m, and then saving it back to x. This is just a really shorthand way of writing this. Alright. And that should work, unless I'm missing something. Let's see. Yeah, there we go. So it orbits us. Perfect. One thing I don't like, and I've never liked, you could leave it at this, but when you start walking, you see how it kind of tries to still orbit you and can't. Now, it would look fine if you had the values plussing each time. Like, it would look fine, but I don't like that. So let's write a little function here, a little if statement. I'll write it, and then I will explain it properly. So if exclamation mark changed of the owner's position, then do this. Else, let's copy this big block down here, and we're going to take out the cosine and the sine values, and we're just going to leave it at 0, 0. Okay, so let me explain this properly. What this basically says is it gets the owner's position, and it says if the owner's position has not, which is the exclamation mark, has not changed, so if the owner has not moved, then orbit. Else, if the owner has moved or is jumping or their position is changing in any way, then stay at a single point, which is 0, 0, which is the character's center. Stay at the character's center, and then just follow them that way. So let's save this, put that out. So now it still orbits us perfectly fine, but when we move, it goes to our center and follows us in a straight line. And when you go back to stopping, it orbits you again. So there you go. Hope you guys enjoyed. Thanks for watching, and have a great day.